Okay, well, let's go ahead and get started. This is a recording of a training video for zTuneUp AI. zTuneUp AI is a companion to the image focus inspection platform, and its primary purpose is to uh, support the platform and to expand on and display the content that is produced by the platform during an inspection. What's unique about zTuneUp AI is that its primary focus is the process of upgrading from one release of ZOS to the next. And so as you'll see, as we get into the demo, this essentially requires us to make two inspections. One of the current system, that is, we discover the environment itself and the configuration of the IPL path, inspect it at its current ZOS release level to determine if there are any risks that might be associated with that need to be corrected before we go on and commence our work attempting to upgrade to a new release. Assuming we do or don't make those changes, a second inspection will be run at a targeted release level. So if you're at 2.5 and you want to go to 3.2, uh, zTuneUp AI will support that. What happens once those inspections are complete is that the results are presented in a dashboard that allows you to compare the risk associated with the current release against the future release that you're attempting to get to. And then from there, you can drill down into all kinds of analytics that will support a better understanding of those risks by driving you directly into the various logs at those points in the logs where the risk actually exists. In addition, two other unique features in zTuneUp AI are its ability to capture dynamic changes and to track those dynamic changes while you're in the process of migrating from one release to the next. Now, a dynamic change is a change in the configuration, generally to LPA, link, BPX, APF list, etc., that are accomplished through the use of set commands like setprog that modify the configuration dynamically by placing those changes in memory. But those changes don't get hardened into the actual configuration. And so if they're not taken into consideration, then some failure might result in the future when you attempt to IPL without having actually hardened those configuration components. The second uniqueness is that it will maintain a baseline of both the content of dynamic changes as well as base configuration changes during your work so that you can actually keep track of changes that are going on as you begin your work. A baseline is taken automatically. And then as you continue through time, you can continue to check against that baseline to actually see what changes have actually been made. So let's go ahead and actually begin a demo here. So what's unique, another uniqueness of zTuneUp AI is that its interface is through basic TSO ISPF. So it doesn't require a VTAM application as would be a requirement for getting to the ICE primary menu and then subsequently to the interface for image focus. So I'll go ahead and log on. And of course, we're going to ISPF. Oh, if I can type it right. Okay, so now we're at the command line of the ISPF primary option menu. And as I mentioned, this is the interface that we're going to use in order to reach zTuneUp AI. In order to do that, the access to the program is driven by a TSO command that is kicked off as follows: TSO $command line interface, comma, asterisk TUIDE. Now, this is a licensed component of the ICE environment, and so you will need a license for this specific LPAR in order to reach this panel, and such a license can be easily obtained from New Era Technical Support. And once you have it, you would place it in your NSE PRM ICE configuration member, and from there you should be good to go. Now, each user has their own view of their work as they go forward with the attempt to move from one release of ZOS to the next. So you can see on this particular panel up at the very top that we define two system IDs, the source ID, ZOS, SOW1, and a target ID, SOW2. Now, in this particular instance that I'm demoing, they're both the same because we want to understand the risk in this particular system, both at the current release level, which has been discovered to be 2.5, and a target release level, which is defined as 3.2. Now, it's possible that we could have another target that we want to compare here. It could be SAL 2 if it was available to us in the environment in which we're actually running it. So it doesn't have to be the same, but if you decide to change it, you better pay a little attention to the availability of that system because an attempt will be made to profile it. And if it's available, everything will go forward. If it's not available, then we'll encounter a system failure. You can see the stack of inspectors that are the target of each of the inspections. So OPSIS, JES, what we call Z-AIDS, this includes the health checker, ICSF, ZOSMF, ZSF, and of course HSM, VTAM, CICS. Notice that in the case of CICS, you also need to specify the suffix of an additional command member that will contain the start of the CICS system. Again, technical support can help you in setting that up if that's necessary. TCP/IP and its components, resolver, profile, telnet, TCP data, FTP, OMP route, and IPsec, servaught, and pageant. Now, each one of these has been inspected using the configuration of the source when we entered the panel itself. And so if we have previously performed an inspection, we will have something actually to go and explore. If we happen to be coming into this for the very first time, there will be no inspection available, and all of these little cubes, red and green and yellows, will all be white to indicate that we need to actually kick off an inspection in order to get a result that can be subsequently analyzed in future logon attempts. Assuming we have an inspection in place, we can put the cursor under, for example, OPSIS, and it will tell us what the risks are, the errors, the warnings, and the notices in the current configuration, that is the source configuration, the one that we're beginning with. And it not only gives us the number of the error itself, in this case IFO 499E, but also the number. There's 1 in this case. If we put the cursor under that message and press enter, we'll go directly into the log. I sometimes refer to it as a trace that tells us exactly where that message is, line 188, and what it's referring to, secure boot failure, etc., etc. Now, it's possible that we may not be interested in secure boot as a component of our analysis, and so we don't deem this risk as being significant relative to the overall objective of migrating to a new release of ZOS. So we could come back and place a value like that, a configuration message or an inspection message on an exclude line. And if we were interested in seeing all the possible excludes, we could put the cursor under exclude and press enter. And this in turn would give us a listing of all of the excludes, and we could in fact include them. Now you can see here in this case, I have not excluded 499E, but have decided that 496E is worth including. And so I've included it here on this line. If I wanted to do a second one, like IFO 0 499E, I could just put a comma and then put the appropriate message number that I choose to exclude. So it's relatively straightforward. We'll get a summary of those things that were included when we finally complete our analytics and show the results in the follow-on dashboard. The same thing is true for all of the other components here. So here's JES, and we can see what the JES messages are. So if we press PF5, we'll just simply go down through those 5 instances of that particular JES message, and then we can make a decision as to whether or not we want to exclude or not those messages from the analysis that we're about to perform. Some components, for example, in this case, the Z-aids, have not been kicked off in the inspection, and so they are shown as simply informational messages. So there's really no risk associated with any of them that has been reported, and so we can just pass over those. VTAM, we have a warning, and again, we can look at the excludes. And we can see there are a number of them here. You'll notice that one of the differences here is that if we decide to exclude it, we have to put it on the exclude line, and we have to check the exclude line in order to tell the process that we actually want that excluded. In the case of VTAM, we don't have anything on the exclude line, and we don't have anything excluded. But if we wanted to, we could simply pick one up. So this one, could copy it, go back, put it on the line, but not check it. So it'll just simply stay here essentially as a placeholder for future inspections if we decide to exclude 687W for VTAM, then the system would do that automatically. Same things apply to CICS. Remember, you have to put suffix of a command number here. Same thing applies to TCP/IP and, of course, IPsec. So once we have everything set the way we want, we have a couple of more options that we can take. For example, it's possible that we might want to include a trace in our analysis. And so if we did, we would click trace. If we don't need to see the trace, that is, we've been through this several times and we don't really need to see it, we don't think there's any advantage to be gained through exploratory data analysis of the trace itself, since the system is designed to overcome any difficulties that might happen in EDA. The second option is to present the index panel that is commonly shown in image focus inspection when we use the image focus VCAM interface. So we can turn both of those on if we want to. I'll leave them on for this purpose. And we can then turn them off if we decide that we want to do it. So the next step we have to take is to kick things off. So put the cursor on kick off or underneath it and press enter. We'll get a small intermediate panel that says continue source discovery. Now you'll notice here that this is telling us what system we're going to inspect, what release level we're at, what inspectors we're turning on in addition to the OPSIS, JES, VCAM, TCP/IP, CICS, and then the suffix that is used for CICS. If we find that that is appropriate, then we can click underneath Continue Discovery, or if we see something that we feel is incorrect, we can just simply hit PF3 and will be returned to the primary menu. So we want to go forward, so we'll do that again. We'll click on Source Discovery because we want to go forward. Now, remember I said that there's going to be two inspections in line. One of the source configuration. It's our baseline. We want to know if there are any risk in it that exists at this moment. And if there are, we might want to take action to correct them before we attempt the full migration. The inspections will take somewhere between 1.5 to 2 minutes. It just depends on the performance of your system. I'm on a ZPDT, so this may take a little bit longer than it might take on your system. Again, the yellow text at the top indicates the target, in this case, source, information that's being passed to image focus. Notice up at the top, at the report index for source. Okay, so this indicates that this particular index report has been prepared from information that has come from the inspection of the source configuration as it currently exists on the system in which you are logged on to. Remember that zTuneUp AI depends on the rule-based retrieval content mechanisms that are embedded into the image focus platform that make it a form of basic AI capability. That is, the machine learning capabilities of image focus have been embedded in it by our data scientists, by them studying the rules and experiences of their own and from customers into if-then logical statements, which is true. That is a form of machine learning. But what's more critically important is the retrieval part. That is the ability to identify and extract the components of a running ZOS system and then apply those rules to each and every one of those extracted components to determine, as you can see here, whether there are warnings in the OPSIS or perhaps errors in JES, as the case may be. So this is the index report. If we go forward, this is the trace or the log. And in this particular instance, this guy is 22,720 records long. So manual exploration of this content can be daunting. But it's not only difficult to navigate, but it's also presents an opportunity for overlooking many of the features and results and insights that image focus is capable of presenting to a user in the log itself. And that's one of the key issues that we're trying to overcome with zTuneUp AI. Now, when I press PF3, we'll see another pop-up that says continue with the target discovery. And you notice here that here we're looking at the same VCAM user ID on the same system, but we're going to perform the inspection at a different level, in this case 3.2. And so this is going to help us to identify certain risks that might materialize that needs to be addressed if we were to attempt to take the current configuration as defined, as we just inspected it, and say, hey, let's do the same thing again, but as if it was a 3.2 system. We do that by creating a virtual 3.2 environment. So this is another one of the key advantages of the image focus platform, that it allows us not only to inspect reality, but it also allows us to inspect virtuality of images that may or may not exist at release levels that we may or may not have installed at a particular point in time. So I'll go ahead and press enter. Now, the first thing that happened here was image focus said, okay, I know what you want me to do. So I'm going to change rule sets here. I'm going to go from 2.5 to 3.2, and I'm going to apply that if-then logic and the retrieval-based mechanisms that I have for identifying a platform and its content along the IPL path. And I'm going to apply those 3.2 rules to what I find. Okay, so we're done with that inspection now at this point. And you can see up at the top here, this index report now says target. So what this means is that these are the inspection results for the target that we identified as being the one that we want to upgrade to. All the functions that you see here, all of the items, turning things on and off, whatever the case may be, are all functional as if we were operating under the VCAM environment, so common for many of you when you use image focus for a similar purpose under the full image focus inspection menu. When I hit PF3, we go to the log. Notice here, this is telling us we're inspecting at 3.2. So there has been a dynamic change here in what it is we're actually inspecting for. When I hit PF3 again, we get a dashboard that shows us our stack, OPSIS, JES, AIDS, VCAM, CICS, TCP/IP, IPsec, and the findings for each of them, identifying the risk in the source and in the target, errors, warnings, notices. Notice in the case of the OPSIS, they're the same. And so if we look over to the right, we notice that it says we have 154 items that have been identified, but there is no change in the risk profile associated with those findings when we compare the source and the target. On the other hand, look at JES. JES says when we look at the source, we have 65 warnings, 1 exclude. When we look at the target, we have 65 errors and 1 exclude. So from a change perspective, as we look at a comparison of the source and the target, we've eliminated 65 from 1 by deletions, and we've added 65 to it when we went to the new release. And so there is a process for identifying the changes here that can be visually examined to determine what changes are taking place between the source and the target so that you could evaluate the change in risk from one release level to the next. Now, if you place the cursor under one of the inspector names and press enter, you'll notice that the lines turn white. So the row that the inspector results on are shown in white, and then the detail of the inspection is shown down below. And so you can see in the source that we have, for example, 5 notices here that we might want to go take a look at. And so here are those 5 notices as they appear in the trace. This is the source, of course. If we PF3 back, now we can go and look at the same thing in the target. Well, this now is the target, so we can see them here as well. Now, in this particular instance, they're the same. There's no difference between one or the other. And the same thing is essentially true throughout all of this stack that I'm currently using, other than for Jez. Up at the top, we can look at the excludes. So here are the things that have been excluded. We said we're not concerned about any associated risk with secure boot, at least as it relates to FLPA or MLPA. And I think there's another one down here. Yeah, DLPA. We're not interested in that. We don't need to focus on that because that's not something that's going to impact our migration. That'll be constant between both systems. And we can see that here when we look at both different traces. So, and then this is the target. You can see that up here. And the same inspection results are shown. So when things are the same, that means that the same level of risk will exist between the source and the target. And if the problem exists in the source, then we need to go fix that before we attempt any kind of upgrade activity. Now, if I select Jez, I'll get a slightly different result. In this case, we have 55 Jez warnings, 153W. Those are coming from Jez, not from image focus. And here's what those look like. And you can take action accordingly based on that. And when we look at that similar message, now remember, this is 153W. This is 151E. This is a different message that's coming out when we do the inspection at 3.2. And again, things are highlighted to allow you to move from one to the other. Simply by pressing PF5, you can simply scroll down through all the messages to get an understanding of essentially what's wrong. One of the primary advantages that I like about this presentation is it presents the results in context as it would appear in the trace itself. So you can see what's happening within the Jez inspection, both before and after the inspection actually takes place. You can continue on down doing the same thing for the rest of these if you choose to, TCP/IP. No rule changes here, no excludes. Same basic idea. Here's a message in the target that was generated by CICS. We have a notice here that there's a CICS newer release that's available. Now, what's important about that is that as one of the migration steps that you likely want to take is to make sure that all the ZOS subsystems will be up to the same level as the ZOS that you're going to. Now, in the past, it was quite possible that Jez and VTAM and perhaps even TCP/IP may be at different release levels from the primary operating system. That's not a best practice and not generally in place or available today, but it is possible that CICS could be at a different release level than the most current one. And this message is intended to make sure that you focus on the fact that you probably also want to upgrade CICS as well as any other component because this could potentially create a risk. Of course, all of this is available for view, copy, print, then even email it if you choose to. If you support the different forms of email, SMTP or communication server, SMTP, that is supported as well. You can put in your message and subject, et cetera, et cetera. Some companies may allow this, some companies may not. There may be restrictions on where this email might be able to go. You definitely want to check out with your security people and risk administrators before you attempt to set this up and use it. This does require some setup in the NSE ENS member in ParmLive, particularly in creating a default method block that can use a defined configuration. So technical support could help you with that if you need it. In addition, there's two other things here that I mentioned earlier. One is dynamic changes. In this case, you can see the dynamic changes that we are tracking: SIMList, APFlist, BPX, BPM, mount, LPA, and linked list. And if everything's the same, that is, that it's no different from the baseline that was automatically created the first time that you came into zTuneUp AI, then everything will be the same. But if something has changed since then, now what do I mean by since then? You can see here that this particular baseline is dated August 8th, 2026 at a particular point in time and was built for a particular user, in this case, me. Each user, as I mentioned earlier, will have their own instance of this. And so each user can have their own baseline and track their own changes as they see the need to do so. If you want to update the baseline, you can put the cursor under update the dynamic baseline and it will update. And when the panel resolves itself, everything will be the same. You can see the baseline, pretty simple. And you can see any excludes. Now, these are, you might think of these in an AI sense as weights or biases that you want to inject into the process itself, where you have defined, in this case, a series of module names that might frequently skew the results of dynamic change analysis, and you want to exclude them. And so these are here displayed for you. Again, technical support can give you advice on how to set this up. If we actually found a hit, that is, if we actually found that one of these names actually existed in the LPA list, we'll put an asterisk in the front of it so that you can see that we've eliminated it. But if not, if we didn't find it, then it would be like this rack cert. We didn't find it, and therefore, obviously, it wasn't eliminated. Again, there's a number of things we can do here to upgrade things if we choose to. Another component is the baseline itself. And you can see here that this particular baseline is dated 8/13/2026. Why would it be different from the other one? Well, it would be different because you chose to make it different. You decided that you knew what the changes were up to that point and you didn't need to track them any further. But from that date, there have been two changes. There have been no adds, no deletes. We still have 103 common members. We still have 101, which show no difference, but we have two that are different. And if we put the cursor under that and press enter, we'll get this panel, which will display for us a dashboard of sorts with member names in it as needed. And these are particularly for changes. If we put the cursor under the member name and press enter, then we'll get a listing of what actually changed. So in this case, we have IEA SIS, that's the member that we selected. The baseline source tells us that these components have been deleted, okay? And if we page down, the new target tells us that these two components have been added. So in the baseline, we had clock XX. In the actual member, clock is 00. In the baseline member, we had auto as 00, comma XX. And the actual member that was inspected is 0, comma AG. So these are the two changes. But if we go down a little further, whoops, sorry about that. We'll see the full member. So these are the two components. The CLPA was not changed, so it didn't show up, but clock and auto did. And so we not only see how it changed from the baseline's perspective, we see what it changed to in the real member, and then we can see the actual member itself. Okay, so we can view the trace here. We could go view the baseline, probably worth looking at. The baselines are not the actual configuration, but in fact are extracts of the configuration from the trace log itself. And the reason we do that is because we want to create tokenization of all of the records that are in a particular container, where the container represents a particular member, in this case, a pseudo member called IPL path. This can be used for a number of different reasons. One, it's a very quick way of determining whether or not there are changes that have taken place between the baseline and the configuration by simply comparing the token and not the entire content. But it also can be used for compliance, audit, and nefarious kind of activities to identify them, because we check the content of the baseline against its token before we begin the process. And if somebody had gotten in here and monkeyed around with this, we could identify that and point it out to you. Okay, well, that's pretty much the overall process. Let me back up here now. Go back in one more time. Just want to point this out. If you have an active configuration and it has been inspected, you will always come back to the same starting point that you were at when you last left. So everything is remembered. Everything is identified to you as an individual user. A couple of points on the panel worth pointing out. This is the name of the application itself, zTuneUp. This is the date when it was first released, in this case, 8/13. This is the actual image focus platform support uh, member, IFO 19H31. We've already talked about everything else here, trace, index, but we can go to findings when we come back in to say, where were we? And we'll get that same panel that we looked at that was a dashboard of sorts. But if we put the cursor under one of our inspectors in the stack and press enter, we're going to get a message that says finding is out of date. You have to kick off a new discovery. And so you cannot get to any of the underlying detail of a finding until you actually create a new inspection. Now, there's two exceptions to that. Dynamic changes will always be available, so you can always get to that if you need to. If you want to see where you are with your baseline, maybe you want to update the baseline before you begin this new session. You can always do the same thing with zTuneUp baseline. You can always see where you were, but if you want to, you could update the baseline again because you're starting a new session. You may have already reconciled all the changes. You don't need to carry the old baseline forward. You just want to go ahead and move forward with a new representation of the baseline itself. So again, zTuneUp AI is a supporting AI agent of the image focus inspection platform. Its intended purpose is to give you better insight into the findings that image focus produces and displays in its inspection log. The inspection log itself is a wealth of information, but because it will sometimes run between 20 to 25,000 records long, exploratory data analysis within it can be daunting. This guide is designed to overcome that, as well as allowing you to run two inspections in parallel, comparing the risk of the two at one release level versus another, and to give you additional insights into dynamic changes and baseline changes. If you need additional support and help with this, it's possible to request it from technical support. If you need a temporary license to test the technical support can help you as well. Okay, well, thank you very much for your support and thank you for your attendance today. We look forward to working with you in the future.